Our world is just full of rules that have more than one condition, right? From speed limits to sales promotions, they're everywhere. Well, in algebra, we've got a really cool tool for this, compound inequalities. So let's break down exactly how they work.
I mean, think about it. A movie rating might be for ages 13 and up, but only with a parent. Or maybe a sale price is only good after Tuesday, but before Friday. How do you actually write a single, clean rule that captures both of those conditions?
Well, that's exactly where compound inequalities come into play. At their core, they're really just two simple rules that are connected together. The real magic, though, is in the kind of glue you use to connect them.
And when it comes to math, we've really only got two main types of glue. You've definitely heard of them. They're the words and or. But you'll see their mathematical meaning is incredibly precise.
So here's the deal. And is super exclusive. It's what we call the intersection, meaning a number has to satisfy both conditions to be in the club. You got to think of it as the overlap. Or, on the other hand, is totally inclusive. It's the union. A number just has to satisfy one of the conditions to be part of the solution. It's everything from both rules all thrown together. Okay, let's dive into our first type, the and inequality. Honestly, the best way to think about this is what I call the sandwich graph, because the solution is always, you guessed it, sandwiched right between 2 points.
Here's a classic example. Now this looks like one statement, but it's really saying two things at once. X has to be greater than or equal to -3, and X has to be less than 2. Let's get this on a number line to really see what's going on. Okay, first things first. We mark our endpoints, -3 and 2. Now pay close attention to the circles. At -3, we use a closed, filled-in circle because of that or equal to sign. It means -3 is included. But over at 2, we use an open circle because X has to be strictly less than 2. So finally, we just shade the region between them. That shaded part right there, that's our sandwich. It's the set of all the numbers that make both conditions true.
All right, now for our second kind of glue, or. With or inequalities, the graph looks totally different. This one I like to call the wings graph, because the solutions kind of fly off in opposite directions.
See how this is written? It's two completely separate statements, joined by that big word or. That's a huge clue. It means a number can either be less than -1, or it can be greater than or equal to 3. It can't possibly be both at the same time.
Graphing this is super straightforward. We just handle each piece one at a time. For the left wing, we pop an open circle on -1 and shade everything to the left, forever. For the right wing, we use a closed circle on 3, thanks to that or equal to sign, and shade everything to the right. See? The two shaded areas just spread out, just like a pair of wings.
Okay, so we've got the mechanics down, but now for the really important part. Let's connect this to the real world and, maybe more importantly, look at some of the common traps people fall into so you can just sidestep them completely.
You see stuff like this all the time. Here's a rule you might see on a sign at an amusement park. This sentence, it's secretly a compound inequality just waiting for us to translate it into math.
Let's just break it down. At least 48 inches, well, that means your height, let's call it h, can be 48 or more. So h is greater than or equal to 48. Under 78 inches means h has to be strictly less than 78. Now, since a rider has to satisfy both of these rules to get on the ride, what's the logical glue? It's got to be and. And because it's an and rule, we can squish those two pieces into one clean, compact statement. 48 is less than or equal to h, which is less than 78. And there you have it. That is the official rule translated perfectly into the language of math.
This card dashboard idea is a perfect example of and versus or out in the wild. The green safe range is an and condition, right? The RPM has to be above 1,000 and below 6,000. But that red warning light, that's an or condition. It'll flick on if the RPM is too low or if it's too high. Same numbers, two totally different rules.
Okay, now for a major pitfall. You cannot write an or statement in that compact sandwich form. You just can't. It doesn't make any sense. A statement like 3 is less than x is less than 1 would mean you're looking for a number that's somehow bigger than 3 and smaller than 1 at the exact same time. It's logically impossible.
All right, the second common mistake is just endpoint confusion. My advice, don't rush it. Always look at each sign by itself. Ask yourself, does it have that little or equal to bar underneath? Because it is absolutely normal for one side of a sandwich graph to have a closed circle while the other side is open.
So what's the big takeaway from all this? This isn't just about numbers on a line, you know? It's a precise language. It's the language of safety regulations, of age restrictions, of operating ranges for machines. It is literally how we define the boundaries that shape the world all around us.
And that leaves us with a final thought to chew on. From the temperature range on your thermostat, to the passing requirements for a class, to the time you have to be home by, what rules in your own life right now are secretly just compound inequalities in disguise?